Introduction: The Paradox of the Stars. There is a question that humanity has carried for as long as we have looked up at the night sky, a question whispered in ancient caves and asked again through the most powerful telescopes we have ever built. Where is everyone? If the universe is so vast, so old, so filled with countless worlds, then why does it feel so empty? Why have we never heard from anyone else? Tonight, we will explore this mystery together, not with urgency or anxiety, but with the gentle curiosity of those who have set aside the demands of the day and allowed themselves to wonder about deeper things. We will drift through theories and possibilities, through the science and philosophy of cosmic loneliness, and perhaps find something beautiful in the not knowing. I hope you have found a comfortable place to rest, somewhere quiet, somewhere safe. However your day has been, whatever weight you're carrying, you can let it go for now. This is your time. Time to breathe, to settle, to let your mind wander through questions that have no immediate answers and no pressing deadlines. If you find value in these quiet hours we share, if this space brings you peace or helps you rest, I would be grateful if you would leave a like or subscribe to the channel. It helps others find their way here, to this same stillness, this same wandering beneath the stars. But for now, let all of that fade. Let everything fade except the sound of this voice and the vastness it will guide you through. Close your eyes if you have not already, settle into whatever surface holds you, and let us begin our journey into the Great Silence. Chapter 1: The Great Silence. There is a question that lives in the space between sleeping and waking. It drifts through the quiet hours when the mind grows soft and the world outside fades into shadow. It's a question older than cities, older than language itself, and it asks simply this: are we alone? For thousands of years, human beings have looked upward and wondered. We have told ourselves stories about gods and spirits, about travellers from distant realms, about lights in the sky that moved with purpose and intelligence. We've imagined ourselves as children in a crowded universe, surrounded by wisdom and wonder, waiting only for the moment when someone, or something, would reach down through the darkness and say hello. But the universe, it seems, has remained silent. This silence has a name. Scientists call it the Fermi Paradox, though the question it asks is anything but paradoxical. It is devastatingly simple. If the universe is so vast, so ancient, so filled with countless stars and worlds, then where is everyone? Where are the signals, the cities, the signs of life beyond our own? Where are the others who must have looked up at their own skies and asked the very same question we're asking now? The numbers suggest we should not be alone. There are hundreds of billions of stars in our galaxy, and hundreds of billions of galaxies stretching outward into the infinite dark. Many of those stars are older than our sun. Many are surrounded by planets, some rocky and warm, bathed in light that could nurture oceans and atmospheres, and the slow, patient unfolding of life. If even a fraction of those worlds gave rise to intelligence, the galaxy should be teeming. We should see their footprints everywhere. Megastructures harvesting starlight, radio waves cascading through the void, probes drifting between solar systems like silent emissaries, carrying messages we have not yet learned to read. And yet, when we listen, we hear nothing. Only the hiss of cosmic radiation, the faint murmur of hydrogen clouds, the echoes of stars being born and dying in the deep. This is the Great Silence. It is not an absence of sound exactly, but an absence of meaning. A universe that hums and crackles and roars, but never speaks. For decades now, scientists have pointed massive radio telescopes toward the sky, listening for patterns in the noise. They scan distant stars, hoping to catch a flicker of intention, a rhythm that cannot be explained by physics alone. Organizations like SETI, the Search for Extraterrestrial Intelligence, have devoted themselves to this vigil, waiting patiently for a signal that has not yet come. Perhaps it will arrive tomorrow. Perhaps it arrived long ago and we simply did not recognize it. Or perhaps the silence itself is the answer, and we are only beginning to understand what it means. Some nights, when the air is clear and the stars press close, it is easy to imagine the universe as it might have been in our stories. A place alive with voices. A place where light-speed highways connect to distant suns, where ancient civilizations share their wisdom across the millennia, where we are not an accident but part of a grand conversation that spans the stars. But other nights, the silence feels heavier. It feels like a weight pressing down on the chest, a loneliness so vast it becomes difficult to name, because if the universe is silent, then perhaps we are not waiting to join a conversation. Perhaps we are the first words ever spoken into the dark, or perhaps we are the last. The question has no easy answer. It branches and divides into 100 smaller mysteries, each one strange and unsettling in its own way. Every explanation for the great silence carries with it a kind of shadow, a possibility we're not quite ready to face, and yet we ask it anyway, because the question itself is what makes us human. The need to know, the refusal to look away. In the chapters ahead, we will walk together through these possibilities. We will explore the theories that scientists and dreamers have offered up in response to the silence. Some are hopeful, some are terrifying. Some suggest that the universe is stranger than we ever imagined, and that the answer to our question may lie not in the stars above us, but in the very nature of reality itself. For now, though, let us simply sit with the silence. Let us feel its presence, the way one might feel the presence of an ocean at night, vast and patient and impossibly deep. Somewhere out there, beneath skies we will never see, on worlds we will never name, life may be unfolding in ways we cannot predict. Or it may have already risen and fallen, leaving behind only dust and ruin and the faint memory of light. We do not know, we cannot know, not yet, but we can listen. We can wonder. And in the wondering, perhaps, we can find something that feels almost like companionship in the dark. Chapter 2. The Fermi Paradox. The year was 1950. A physicist named Enrico Fermi sat with colleagues in a cafeteria at Los Alamos, where some of the brightest minds of the age had gathered to reshape the world with mathematics and fire. The conversation had turned, as conversations sometimes do, toward the improbable and the impossible. They spoke of flying saucers, of recent reports in the newspapers, of strange lights moving through American skies. And then Fermi asked a question that would outlive him, 4 simple words that would echo through decades of science and speculation. Where is everybody? It was asked casually, almost as a joke, but the question hung in the air like smoke, impossible to dismiss. Because Fermi understood what the numbers implied. He understood that if intelligent life were common, if it arose wherever conditions allowed, then the galaxy should be crowded beyond measure. Even accounting for the vastness of space, even allowing for the slow crawl of light between stars, civilization should have had time, millions of years, billions perhaps, time enough to spread, time enough to build, time enough to leave marks upon the cosmos that could not be ignored. Our own galaxy is ancient. It formed more than 13 billion years ago, when the universe itself was still young and strange. Our sun, by comparison, is middle-aged at best, a latecomer to the stellar congregation. There are stars out there that burned bright when Earth was nothing but dust and possibility. Stars that could have nurtured worlds and minds long before our own ancestors learned to walk upright beneath African skies. If even one of those civilizations had survived, had learned to travel between the stars, they could have colonized the entire galaxy by now. Not quickly, perhaps, not in a single lifetime or even 1,000 lifetimes, but slowly, patiently, moving from star to star like seeds carried on an endless wind, they could have claimed every habitable world, every promising moon, every asteroid rich with resources, and yet we see no evidence of this, no vast networks of artificial structures, no terraformed planets glowing with unnatural light, no signs that anyone, anywhere, has ever done what we ourselves dream of doing. This is the heart of the Fermi Paradox. Not merely that we have not detected alien signals, but that we have not detected anything at all. No ruins, no relics, no fingerprints upon the fabric of space itself. It is as if the universe has been wiped clean, or as if we are looking at a stage before the actors have arrived. Some have tried to resolve the paradox by suggesting that space is simply too large, too empty, too difficult to traverse, and this is true, in a sense. The distances between stars are almost incomprehensible. Even travelling at a significant fraction of light speed, a journey to the nearest star system would take decades. Reaching the far side of the galaxy would require millennia. But time, in this calculation, is not the obstacle it first appears to be, because the galaxy itself is older than we can easily imagine. If a civilization began sending out ships 1 million years ago, travelling slowly and steadily, stopping to refuel and rebuild at each new star, they would have had time to visit every star in the galaxy many times over. Even without faster-than-light travel, even without any technology beyond what we ourselves might achieve in the next few centuries, the galaxy could be conquered by patience alone. And so the question remains, where are they? Perhaps the answer is that intelligence is rare. Perhaps the chain of events that led to us, to beings capable of asking questions and building telescopes and wondering about the dark, is so improbable that it has happened only once in the entire galaxy. Perhaps we are not waiting for others to arrive. Perhaps we are the first. Or perhaps intelligence is common, but survival is not. Perhaps there is something that awaits every civilization, some threshold or test that most cannot pass, a great filter that removes species before they can reach the stars, leaving behind only silence and ruin. Perhaps they are out there, but they are hiding. Perhaps they have learned something we have not yet learned, something about the nature of the universe or the dangers that lurk within it, and they have chosen silence over contact, invisibility over expansion. Or perhaps the silence is deliberate in a different way. Perhaps we are being watched, studied, preserved like specimens in a cosmic museum, and the watchers have agreed among themselves never to interfere, never to speak, never to let us know we are not alone. Each of these possibilities opens onto others, like doors in a hallway that stretches into darkness, and each one carries with it a different vision of what the universe might be, and what our place within it might mean. Fermi himself never lived to see how deeply his question would burrow into the scientific imagination. He died just 4 years after asking it, his mind already turning toward other mysteries. But the question he left behind has become one of the defining puzzles of our age, a riddle that touches on everything from biology to philosophy to the ultimate fate of conscious beings in an indifferent cosmos. It is a question that keeps astronomers awake at night, staring at data streams and radio frequencies, hoping for the pattern that will change everything. It is a question that haunts those who look up at the sky and feel, suddenly and without warning, the terrible weight of all that empty space pressing down. Because the paradox is not just about aliens, it is about us. About what it means to be intelligent and fragile and alone in a universe that does not seem to care whether we survive or disappear. Somewhere in the distance a satellite drifts through the void, its instruments trained on a patch of sky no human eye will ever see directly. It listens, it waits. And the universe, for now, offers nothing in return but the static hum of its own existence, ancient and patient and vast beyond all measure. Ready for Chapter 3 when you are. Retry. A. Please proceed. Orchestrated poetic continuation maintaining tone and structural constraints. The user wants me to continue with Chapter 3, the Drake equation. I need to maintain the same dreamy, meditative tone, use 1s and 2s breaks only, spell out acronyms phonetically, and keep the word count around 1,000 to 1,200 words. I should avoid repeating imagery from previous chapters and create a fresh, poetic ending. Chapter 3, the Drake equation. Before Fermi asked his question, another mind was already reaching toward the stars with mathematics. His name was Frank Drake, and in 1961 he gathered a small group of scientists in a place called Green Bank, nestled in the quiet hills of West Virginia, where radio telescopes stood like monuments to human curiosity. They had come together to discuss a problem that seemed almost absurd in its ambition. How many intelligent civilizations might exist in our galaxy? How could anyone possibly answer such a question when we had found no evidence of even one beyond our own? Drake's solution was elegant. If you cannot measure something directly, he reasoned, then break it into smaller pieces. Identify the factors that might lead to intelligent life, estimate each one as best you can, and multiply them together. The result would not be certainty, but it would be something. A framework, a way of thinking about the impossible. And so he wrote an equation on a chalkboard, simple and profound. It began with the rate at which stars form in the galaxy, then moved through the fraction of stars that have planets, the number of planets that might support life, the fraction where life actually emerges, the fraction where that life becomes intelligent, the fraction that develops technology capable of communication, and finally, the length of time such civilizations might survive. 7 variables, 7 windows through which we might glimpse an answer to our loneliness. The equation became known, naturally enough, as the Drake equation. It has been refined and debated and revised in the decades since, but its essential character remains unchanged. It is less a formula than a way of organizing our ignorance, of making visible the gaps in our understanding. Consider the first variable, the rate of star formation. This at least we can estimate with some confidence. Astronomers have watched stars being born in clouds of gas and dust, have measured the light from distant galaxies, have calculated how quickly the universe transforms hydrogen into suns. In our galaxy, perhaps 7 new stars ignite each year, their nuclear fires pushing back against gravity's endless collapse. 7 stars, 7 chances, every single year, for worlds to form and life to begin. The next variable asks how many of those stars have planets. When Drake first posed the question, this was pure speculation. We knew of no worlds beyond our own solar system. The technology to detect such distant, faint objects simply did not exist, but now we know. In the last few decades, astronomers have discovered thousands of exoplanets, worlds orbiting distant suns in configurations both familiar and strange. There are planets larger than Jupiter, circling so close to their stars that their surfaces are molten. There are planets smaller than Earth, frozen at the edges of their solar systems. There are planets in pairs, locked in orbital dances. There are planets orbiting dead stars bathed in the ghostly light of white dwarfs. It seems that planets are not rare, they are the rule, not the exception. Nearly every star we examine closely enough reveals a family of worlds, and the numbers suggest that there may be more planets in the galaxy than there are stars. This changes the equation. It shifts the balance toward abundance, toward the possibility that the universe is richer and stranger than we dared to hope. But abundance alone is not enough. The next question is harder. How many of those planets could actually support life? We know from our own experience that life requires certain conditions. Liquid water, most likely, a stable source of energy, a protective atmosphere, organic molecules capable of complex chemistry. Astronomers have defined a region around each star called the habitable zone, a narrow band where temperatures are neither too hot nor too cold, where water might flow on a planet's surface, rather than boiling away or freezing solid. Some planets fall within this zone. Some are rocky and Earth-sized and orbit stars similar to our own. These are the worlds that capture our imagination, the places where we might, if we squint hard enough, see ourselves reflected. But even if a planet lies in the habitable zone, even if it has water and chemistry and energy, the leap to life remains mysterious. We do not know how life begins. We do not know if it is inevitable, a natural consequence of chemistry given enough time, or if it is astonishingly rare, a miracle that happened once and might never happen again. On Earth, life appeared quickly. Almost as soon as the planet cooled enough to allow it, primitive organisms were already thriving in ancient seas. This suggests that life may be easy, that it emerges wherever conditions permit. But Earth is the only example we have, and drawing conclusions from a sample size of 1 is a dangerous game. The equation marches onward. Of the planets where life emerges, how many develop intelligence? And of those, how many create technology capable of sending signals into space? Here the numbers become even more uncertain. Intelligence, as we understand it, required billions of years to evolve on Earth. It required countless accidents and extinctions, ice ages and asteroid impacts, the rise and fall of species beyond counting. There were moments when it might have gone differently, when the thread of consciousness might have been severed before it could weave itself into language and tools and radio telescopes. Perhaps intelligence is common. Perhaps it is the natural endpoint of evolution, the inevitable result of competition and complexity. Or perhaps it is a fluke, a strange detour that occurred once and will never occur again. And even if intelligence arises, even if it builds civilizations and discovers electricity and begins to wonder about the stars, there remains a final, haunting variable. How long do such civilizations last? This is the question that Drake could not answer, that no one can answer, because we are still here, still surviving, and we do not yet know if we will endure for centuries or collapse before the next generation is born. We do not know if the technologies that allow us to communicate across space are the same technologies that will destroy us if the line between mastery and extinction is thinner than we imagined. When you multiply the variables together, when you plug in your best guesses for each unknown factor, the Drake equation yields a number. But the number changes depending on what you believe. Optimists see a galaxy filled with thousands of civilizations. Pessimists see only us, alone in an ocean of silent worlds? The equation does not tell us what is true. It tells us what we need to learn. It maps the territory of our uncertainty and shows us where to look next. And so the telescopes keep turning and the satellites keep listening, and somewhere in the cold mathematics of the Drake equation, an answer waits to be found. Chapter 3. The Drake Equation. Before Fermi asked his question, another mind was already reaching toward the stars with mathematics. His name was Frank Drake, and in 1961 he gathered a small group of scientists in a place called Greenbank, nestled in the quiet hills of West Virginia, where radio telescopes stood like monuments to human curiosity. They had come together to discuss a problem that seemed almost absurd in its ambition. How many intelligent civilizations might exist in our galaxy? How could anyone possibly answer such a question when we had found no evidence of even one beyond our own? Drake's solution was elegant. If you cannot measure something directly, he reasoned, then break it into smaller pieces. Identify the factors that might lead to intelligent life, estimate each one as best you can, and multiply them together. The result would not be certainty, but it would be something, a framework, a way of thinking about the impossible. And so he wrote an equation on a chalkboard, simple and profound. It began with the rate at which stars form in the galaxy, then moved through the fraction of stars that have planets, the number of planets that might support life, the fraction where life actually emerges, the fraction where that life becomes intelligent, the fraction that develops technology capable of communication, and finally, the length of time such civilizations might survive. 7 variables, 7 windows through which we might glimpse an answer to our loneliness. The equation became known, naturally enough, as the Drake equation. It has been refined and debated and revised in the decades since, but its essential character remains unchanged. It is less a formula than a way of organizing our ignorance, of making visible the gaps in our understanding. Consider the first variable, the rate of star formation. This at least we can estimate with some confidence. Astronomers have watched stars being born in clouds of gas and dust, have measured the light from distant galaxies, have calculated how quickly the universe transforms hydrogen into suns. In our galaxy, perhaps 7 new stars ignite each year, their nuclear fires pushing back against gravity's endless collapse. 7 stars, 7 chances every single year for worlds to form and life to begin. The next variable asks how many of those stars have planets. When Drake first posed the question, this was pure speculation. We knew of no worlds beyond our own solar system. The technology to detect such distant, faint objects simply did not exist. But now we know. In the last few decades, astronomers have discovered thousands of exoplanets, worlds orbiting distant suns in configurations both familiar and strange. There are planets larger than Jupiter, circling so close to their stars that their surfaces are molten. There are planets smaller than Earth, frozen at the edges of their solar systems. There are planets in pairs, locked in orbital dances. There are planets orbiting dead stars, bathed in the ghostly light of white dwarfs. It seems that planets are not rare. They are the rule, not the exception. Nearly every star we examine closely enough reveals a family of worlds, and the numbers suggest that there may be more planets in the galaxy than there are stars. This changes the equation. It shifts the balance toward abundance, toward the possibility that the universe is richer and stranger than we dared to hope. But abundance alone is not enough. The next question is harder. How many of those planets could actually support life? We know from our own experience that life requires certain conditions. Liquid water, most likely. A stable source of energy. A protective atmosphere. Organic molecules capable of complex chemistry. Astronomers have defined a region around each star called the habitable zone. A narrow band where temperatures are neither too hot nor too cold. Where water might flow on a planet's surface rather than boiling away or freezing solid. Some planets fall within this zone. Some are rocky and Earth-sized and orbit stars similar to our own. These are the worlds that capture our imagination, the places where we might, if we squint hard enough, see ourselves reflected. But even if a planet lies in the habitable zone, even if it has water and chemistry and energy, the leap to life remains mysterious. We do not know how life begins. We do not know if it is inevitable, a natural consequence of chemistry given enough time, or if it is astonishingly rare, a miracle that happened once and might never happen again. On Earth, life appeared quickly. Almost as soon as the planet cooled enough to allow it, primitive organisms were already thriving in ancient seas. This suggests that life may be easy, that it emerges wherever conditions permit. But Earth is the only example we have, and drawing conclusions from a sample size of one is a dangerous game. The equation marches onward. Of the planets where life emerges, how many develop intelligence? And of those, how many create technology capable of sending signals into space? Here the numbers become even more uncertain. Intelligence, as we understand it, required billions of years to evolve on Earth. It required countless accidents and extinctions, ice ages and asteroid impacts, the rise and fall of species beyond counting. There were moments when it might have gone differently, when the thread of consciousness might have been severed before it could weave itself into language and tools and radio telescopes. Perhaps intelligence is common. Perhaps it is the natural endpoint of evolution, the inevitable result of competition and complexity. Or perhaps it is a fluke, a strange detour that occurred once and will never occur again. And even if intelligence arises, even if it builds civilizations and discovers electricity and begins to wonder about the stars, there remains a final, haunting variable. How long do such civilizations last? This is the question that Drake could not answer, that no one can answer, because we are still here, still surviving, and we do not yet know if we will endure for centuries or collapse before the next generation is born. We do not know if the technologies that allow us to communicate across space are the same technologies that will destroy us, if the line between mastery and extinction is thinner than we imagined. When you multiply the variables together, when you plug in your best guesses for each unknown factor, the Drake equation yields a number. But the number changes depending on what you believe. Optimists see a galaxy filled with thousands of civilizations. Pessimists see only us, alone in an ocean of silent worlds. The equation does not tell us what is true. It tells us what we need to learn. It maps the territory of our uncertainty and shows us where to look next. And so the telescopes keep turning, and the satellites keep listening, and somewhere in the cold mathematics of the Drake equation, an answer waits to be found. Chapter 4. The Dark Forest Theory. There is a theory about the silence that feels less like science and more like a ghost story told in the dark. It was born not in a laboratory or an observatory, but in the pages of a novel written by a Chinese author named Liu Cixin, and yet it has haunted scientists and philosophers ever since, because it offers an explanation for the great silence that is both logical and deeply unsettling. It is called the Dark Forest Theory, and it suggests that the universe is not empty, but hiding. Imagine the galaxy as a forest at night. You're walking through it alone, your footsteps soft on the ground, your breath the only sound you can hear. You cannot see more than a few feet ahead. The trees are thick and the darkness is absolute. And you know, somehow, that you are not alone, that there are others moving through the shadows, others who can hear your footsteps just as you might hear theirs. What do? Do you call out? Do you announce your presence, hoping to find friendship or alliance in the dark? Or do you stay silent? Do you move carefully, quietly, making yourself as small and invisible as possible, because you cannot know whether the others in the forest are friends or hunters? The Dark Forest Theory suggests that every intelligent civilization faces this same choice, and it suggests that the ones who survive are the ones who choose silence. The logic is brutal in its simplicity. In a universe where resources are finite and civilizations compete for survival, any unknown civilization represents a potential threat. You cannot know their intentions, you cannot know their capabilities, you cannot know if they will greet you with curiosity or destroy you before you become strong enough to threaten them. Communication itself becomes dangerous, because to send a signal into space is to reveal your location, your level of technology, your existence. It is to say, here I am, here is my world, here is everything I have built. And if another civilization receives that signal, if they calculate that you might one day become a threat, the safest course of action is to eliminate you immediately, not out of malice necessarily, not out of hatred or cruelty, but out of the cold mathematics of survival in a universe where trust cannot exist between strangers separated by light years and millennia. This is the Dark Forest, a place where every civilization is both hunter and prey, where survival depends on remaining hidden, where the first one to speak might be the first one to die. It is a chilling vision. It suggests that the silence we hear is not evidence of absence, but evidence of fear, that the galaxy might be teeming with civilizations, all of them listening carefully, all of them terrified of being discovered, all of them watching and waiting in the dark. And it suggests that we, in our innocence or our arrogance, have been shouting into that darkness for decades. We have sent radio signals bearing messages of peace and mathematical proofs. We have launched spacecraft carrying golden records etched with diagrams showing Earth's location in the galaxy. We have announced ourselves to anyone who might be listening. If the dark forest theory is correct, this may have been the greatest mistake in human history. Of course, the theory rests on assumptions that might not hold. It assumes that civilizations are fundamentally competitive, that they view each other as threats rather than potential allies. It assumes that resources are scarce enough to fight over, despite the vastness of space and the abundance of raw materials floating in asteroid belts and dead moons. It assumes that there is no possibility of communication, no way to establish trust or common ground between species separated by unimaginable distances and evolutionary histories. And perhaps these assumptions are wrong. Perhaps a civilization advanced enough to travel between stars would also be wise enough to seek cooperation rather than conflict. But the theory persists because it explains what we observe. It explains the silence without requiring that life be rare or that civilizations inevitably destroy themselves. It suggests that the galaxy might be full of life, full of minds and cultures and histories, all of them simply too afraid to reveal themselves. There is something almost tragic about this vision. The idea that the universe could be rich with consciousness, with beings asking the same questions we ask and feeling the same loneliness we feel, and yet none of us will ever meet because we are all too frightened to speak. That the great silence is not the absence of others, but the presence of fear. Some nights, when the stars seem especially distant, it is easy to imagine the watchers out there. Civilizations millions of years old, patient and careful, their telescopes trained on our yellow sun, their instruments measuring the signatures in our atmosphere that reveal the presence of industry and agriculture and life. They have seen us, they have catalogued us, and they have chosen, for reasons we cannot understand, to remain hidden. Perhaps they are waiting to see what we will become. Perhaps they are deliberating among themselves whether we represent a threat or an opportunity. Or perhaps they have already forgotten us, moved on to other concerns in a galaxy too large for any one species to monitor completely. The dark forest theory does not offer comfort. It does not suggest that we will one day join a galactic community or share our knowledge with beings from distant stars. Instead, it suggests that the universe is a place of solitude and danger, where every civilization must choose between remaining hidden and risking annihilation. And yet, even this dark vision contains a strange kind of hope, because if the theory is true, then we are not alone. We are simply afraid, all of us, together in the dark. And perhaps, one day, someone will be brave enough to light a candle. Perhaps someone will take the risk of speaking first, of trusting that the universe contains more than hunters and prey. Perhaps that someone will be us. For now, the forest remains dark. The signals we have sent spiral outward through space, carrying our greetings to whoever might be listening, and the universe, if it hears us at all, keeps its secrets close and offers nothing in return but the quiet rustle of stars moving through the endless night. Chapter 5. The Zoo Hypothesis. There is another explanation for the silence, one that is gentler than the dark forest, but perhaps equally strange. It suggests that we are not hidden because we are afraid, but because we are being protected. That somewhere out there, older and wiser minds have looked upon our world and made a decision, not to destroy us, not to greet us, but to watch us from a distance, to let us grow and stumble and find our own way forward, like children learning to walk in a room where the adults have quietly stepped back. This is the zoo hypothesis, and it asks us to imagine that Earth is not a lonely island in an empty cosmos, but a preserve, a protected space, a place set aside for observation, where interference is forbidden and contact is delayed until we are ready for it. The idea was first proposed by a radio astronomer named John Ball in 1973. He wondered whether advanced civilizations might have reasons to avoid contact with younger species, not out of hostility or indifference, but out of something resembling care. Perhaps they have learned from experience that contact between civilizations at vastly different levels of development rarely ends well for the younger one. Perhaps they have seen cultures collapse under the weight of revelations they were not prepared to integrate, and so they watch, they observe, they keep their distance, not because they do not care, but because they care enough to let us discover things for ourselves. It is a comforting thought in some ways. It suggests that the silence is not abandonment but patience, that we are not alone but simply not yet ready for the conversation that awaits us. It implies that somewhere in the vastness there are beings who have marked our coordinates, who check on us from time to time, who have perhaps placed invisible boundaries around our solar system, with signs that read, in whatever language they use, "Do not disturb." But it is also a humbling thought, because it places us in the role of the observed rather than the observer, the studied rather than the scholar. It suggests that we are not the protagonists in the story of the galaxy, but a footnote, a curiosity, a species still too young, too volatile, too dangerous to ourselves and others to be trusted with knowledge of the wider universe. What might they be waiting for? What is the threshold we must cross before contact becomes permissible? Perhaps they are waiting for us to achieve peace, to end the wars that have marked our history, to learn how to live together on one small planet before we are invited to join a community that spans many. Perhaps they look at our conflicts, our divisions, our weapons pointed at ourselves, and they shake whatever passes for their heads and think, not yet, not ready. Or perhaps they are waiting for a certain level of technological maturity. Faster than light travel maybe, or the ability to harness the full energy of our sun. Some milestone that would indicate we have graduated from childhood into something approaching adolescence in the cosmic scheme. Or perhaps the criteria are more subtle. Perhaps they are waiting for a shift in consciousness, a moment when we stop seeing ourselves as separate nations and tribes and begin to see ourselves as a single species, a single voice speaking for Earth. Perhaps they are waiting for us to ask the right questions, or to stop asking questions altogether and simply listen. The zoo hypothesis carries within it a peculiar kind of loneliness. To know that you are being watched but not approached. To suspect that there are eyes upon you, but that those eyes will never meet your own until some distant, undefined moment in the future. It is the loneliness of a child who knows the adults are in the next room but cannot yet join their conversation. Some have criticized the hypothesis as anthropocentric, as a comforting fantasy that places human beings at the center of a deliberate cosmic plan. Why would advanced civilizations care about us at all? Why would they dedicate resources to monitoring a species that has barely left its own planet, that has existed for the blink of an eye in galactic terms? But perhaps the answer is simpler than we imagine. Perhaps life itself is precious, rare enough that any instance of it deserves protection. Perhaps intelligence, once it emerges, carries with it a responsibility to nurture other instances of intelligence wherever they appear. Perhaps the advanced civilizations remember their own early days, their own stumbling steps toward the stars, and they choose to give us the same gift they might have been given: space, time, the freedom to become whatever we will become. There is also the possibility that the zoo is not benevolent, that we are being observed not for our benefit but for theirs, that we are an experiment, a study in evolution and sociology, watched by entities who have no more emotional investment in our survival than a biologist has in the survival of bacteria in a petri dish. This darker version of the hypothesis suggests that the boundaries around us are not for our protection, but for theirs, that they have quarantined us, kept us isolated not because we're too fragile for contact, but because we're too dangerous, too unpredictable, too likely to disrupt whatever order they have established among the stars. We cannot know which version is closer to the truth. We cannot know if we are cherished or merely catalogued, if the watchers wish us well or simply wish to keep us contained. We can only continue as we have been, living our lives beneath skies that might be filled with silent observers, building our civilizations and making our mistakes and hoping that when the time comes, when the barriers finally fall, we will be ready for what lies beyond them. There is a story that some tell about the zoo hypothesis, a thought experiment that makes the theory feel suddenly, uncomfortably real. Imagine that tomorrow we detect a signal, not a faint whisper from thousands of light years away, but a clear, deliberate transmission from somewhere just beyond our solar system. A message that says, simply, "You are ready now. Welcome." How would we respond? With joy, perhaps. With fear, certainly. with the sudden, overwhelming knowledge that everything we thought we knew about our place in the universe was wrong, that we have been children all along and the adults have finally decided to open the door. For now, that door remains closed. The zoo, if it exists, maintains its invisible walls, and we continue our work, sending our signals and building our telescopes and dreaming of the day when we might finally meet our watchers face to face, or whatever passes for faces in a universe stranger than we can imagine. Until then, we are alone with our questions, alone with the possibility that we are being seen even when we cannot see in return, alone with the hope that the silence is not indifference, but patience waiting to be rewarded. Chapter 6. The Great Filter. Of all the possible answers to the Great Silence, there is one that keeps scientists awake at night with a particular kind of dread. It is not a theory about aliens hiding in the dark or watching us from a distance. It is a theory about extinction, about the possibility that the universe is not empty because life is rare, but because something stops it. Something prevents civilizations from reaching the stars. Something filters them out, one by one, until the galaxy falls silent again. This is the Great Filter, and the question it poses is terrible in its simplicity. Where is it? Behind us, or ahead? The concept emerged from a simple observation. If the conditions for life are as common as they appear to be, if the universe is as old and vast as we know it to be, then intelligent civilizations should have arisen countless times. And yet we see no evidence of them. No megastructures harvesting the light of distant suns. No radio signals carrying messages across the void. No signs that anyone, anywhere, has ever made it beyond the boundaries of their home world. Something, then, must be preventing this. Some step in the long journey from chemistry to consciousness to spacefaring civilization must be extraordinarily difficult. So difficult that almost no one makes it through. So difficult that the galaxy, despite its age and abundance, remains mostly empty. This is the filter, a barrier, a wall that cannot be climbed. The question that haunts us is where this barrier lies. Because if it is behind us, if it exists somewhere in the early stages of life's development, then we are extraordinary. We are the winners of a cosmic lottery. The rare exceptions who somehow made it through when countless others did not. Perhaps the filter is the emergence of life itself, the first spark of self-replication in a universe of inert matter. Perhaps it is the leap from simple cells to complex organisms, a transition that took billions of years on Earth and might never occur at all on other worlds. If the filter is behind us, then we can breathe easier. The hardest part is over. The road ahead, while challenging, is at least passable. We have already beaten the impossible odds, but if the filter is ahead of us, then we are walking towards something we cannot see. Something that waits for every civilization that reaches a certain level of technological sophistication. Something that has stopped every other species that came before us, and will stop us too unless we are very clever or very lucky. What might it be? What could possibly be so devastating, so universal, that it eliminates nearly every civilization that encounters it? The most obvious candidate is self-destruction. The possibility that intelligence, once it reaches a certain threshold, inevitably develops the means to destroy itself. We have seen glimpses of this in our own history. The moment we learn to split the atom, we gain the power to end our civilization in an afternoon. Nuclear weapons sit in silos and submarines, waiting with terrible patience. We have come close to using them, closer than most people realize, saved only by the decisions of individuals who chose restraint when the world balanced on the edge of fire. And nuclear weapons are only the beginning. As our technology advances, as we gain mastery over biology and nanotechnology and artificial intelligence, we create new ways to end ourselves. Perhaps every civilization reaches this point. Perhaps the moment a species becomes smart enough to leave its planet is the same moment it becomes capable of destroying itself, and the window between these two achievements is narrower than we would like to believe. There are other possibilities. Perhaps the filter is environmental collapse. Perhaps every industrial civilization inevitably exhausts its planet's resources, poisons its atmosphere, disrupts its climate beyond the point of recovery. We are watching this happen in real time. The slow warming of our world, the acidification of our oceans, the extinction of species at rates not seen since the dinosaurs disappeared. Perhaps this is the filter, and we are already caught in it. struggling against a fate that has claimed every other civilization that came before us. Or perhaps the filter is something we have not yet imagined, some challenge that only reveals itself to civilizations more advanced than our own. Perhaps there is a threshold in artificial intelligence that, once crossed, leads inevitably to the replacement or extinction of biological beings. Perhaps there is a law of physics we have not yet discovered, something about the nature of space or time or consciousness that makes interstellar travel impossible or fatal. Perhaps the filter is loneliness itself. Perhaps civilizations that find themselves alone in the universe lose the will to continue, the motivation to reach outward. Perhaps they turn inward instead, becoming lost in virtual worlds of their own creation, abandoning the stars for simulations that are easier and more comfortable than the cold reality of space. The truly frightening aspect of the Great Filter is its silence. We cannot know where it is until we either pass through it or fail to. And if we fail, there will be no one left to record the lesson, no one to warn the next species that might arise millions of years hence. Some scientists argue that we should not look too hard for evidence of life elsewhere, that every dead planet we find, every silent solar system we catalogue, is actually good news, because it suggests that the filter might be behind us, that the journey from chemistry to intelligence is rare enough that we are among the few who made it through. But every sign of life we find, every fossil on Mars or microbe in the ice of Europa, pushes the filter forward. It suggests that life is easy, that the hard part comes later. And if life is easy but civilizations are absent, then something terrible must be waiting ahead. There is a strange paradox in hoping for a dead universe, in wishing that the galaxy is empty not because we are special, but because the alternative is worse, that we would rather be alone than face the knowledge that the silence is made of ghosts, of species that reached toward the stars and fell just short. We do not know which side of the filter we stand on. We do not know if our survival is already remarkable or if our true test is yet to come. We can only move forward, carefully, making choices that might determine not just our own fate but the fate of consciousness itself in this corner of the universe. Because if the filter is ahead, if it is something we have the power to avoid, then everything we do matters in ways we can barely comprehend. Every decision to cooperate rather than compete, to preserve rather than destroy, to reach outward rather than turn inward, becomes a small act of defiance against the silence. A small statement that we will not be filtered, that we will find a way through. The night deepens, and the stars wheel overhead in their ancient patterns. Somewhere among them, perhaps, other civilizations face the same test, or perhaps they have already failed it, leaving behind only ruins and radiation and the fading memory of what they might have become. We cannot know. We can only hope and work and try to be the species that finally makes it through to the other side. Chapter 7. The Rare Earth Hypothesis. There is a quieter explanation for our solitude, one that asks us to look more carefully at the world beneath our feet. Not at the stars above, but at the intricate, improbable series of accidents that led to us standing here at all, breathing this particular air, orbiting this particular sun. It suggests that Earth is not ordinary, not a template that repeats itself across the galaxy. It suggests that we live on a world so precisely calibrated for complex life that its duplication borders on the miraculous. This is the Rare Earth Hypothesis, and it asks a simple question with profound implications. What if intelligence is not rare because civilizations destroy themselves or hide in fear, but because the conditions required to produce intelligence almost never occur? Consider our planet. Not just its size or its distance from the sun, though these matter, but the countless details, the intricate web of circumstances that had to align for life to not merely survive, but flourish and diversify, and eventually give rise to consciousness. We orbit a star that is neither too large nor too small. Massive stars burn bright and hot but die quickly, exploding long before life could establish itself on any orbiting worlds. Tiny red dwarfs live for trillions of years, but they are prone to violent flares that would strip away any atmosphere, bathing their planets in lethal radiation. Our sun is medium-sized, stable, predictable. It has burned steadily for billions of years and will continue for billions more. We orbit at precisely the right distance. A few million miles closer and our oceans would have boiled away. A few million miles farther and they would have frozen solid. This narrow band, this habitable zone, is smaller than we once believed, more fragile. But distance alone is not enough. Mars lies near the edge of the habitable zone, and yet it is a frozen desert. Venus is only slightly closer to the Sun than we are, and yet its surface is hot enough to melt lead, its atmosphere a crushing envelope of carbon dioxide. Something more than position in space is required. Earth has a moon. Not a small captured asteroid, but a massive companion, a quarter the diameter of our planet itself. It was born, most likely, from a catastrophic collision in the early days of the solar system when a Mars-sized object struck the infant Earth and sent debris spinning into orbit. From that debris, the moon coalesced. This moon stabilizes our planet's tilt. Without it, Earth would wobble chaotically on its axis, and the climate would swing wildly between extremes. Ice ages and infernos would alternate on timescales too rapid for complex life to adapt. But the moon holds us steady, keeps our seasons regular, allows life to plan and predict and persist. The moon also creates tides, and tides may have been essential for life's transition from sea to land. The rhythmic washing of coastal zones, the mixing of nutrients, the creation of tidal pools where early organisms could experiment with breathing air. Perhaps life would have remained purely aquatic without these tidal zones. Perhaps intelligence would never have emerged from beings that never left the ocean. We have Jupiter, that massive world orbiting far beyond us with its immense gravity well, acts as a cosmic shield. It captures or deflects asteroids and comets that might otherwise plunge toward the inner solar system. It is not perfect protection. Impacts still occur, extinctions still happen, but without Jupiter, Earth would be struck far more often, the surface repeatedly sterilized by objects falling from the dark. We have plate tectonics. Our planet's crust is broken into massive pieces that drift and collide and subduct beneath one another, recycling carbon and regulating temperature over geological timescales. This process creates mountains and ocean trenches, drives volcanic activity, and maintains the balance of gases in our atmosphere. As far as we know, Earth is the only planet in the solar system with active plate tectonics. Perhaps it is the only rocky planet anywhere with this feature, and without it the climate would have run away long ago, turning Earth into a lifeless twin of Venus or Mars. We have water, vast amounts of it, delivered perhaps by comets in the early days of the solar system. Water that has remained liquid for billions of years, cycling through oceans and atmosphere and ice, nurturing life in all its forms. We have an iron core that generates a magnetic field. This invisible shield protects us from the solar wind, prevents our atmosphere from being slowly stripped away into space. Mars once had a magnetic field, scientists believe, but it faded, and with it went most of the Martian atmosphere, leaving behind only a thin whisper of what once might have been. We have the right chemistry. Carbon and oxygen and nitrogen and phosphorus, all present in abundance, all capable of forming the complex molecules that life requires. We have radioactive elements in our core, keeping the interior hot and driving the geological processes that shape our surface. And perhaps most importantly, we've had time without catastrophe. Billions of years during which the sun burned steadily, the moon held us stable, Jupiter kept watch, and life was allowed to experiment and evolve and eventually produce beings capable of looking up and wondering why the sky is silent. Each of these factors alone might be common. Perhaps many planets have moons. Perhaps many solar systems have giant outer planets that act as shields. Perhaps plate tectonics is not as rare as we think, but all of them together, all occurring on the same world in the same system, maintained for the billions of years required for intelligence to evolve. The probability begins to look very small indeed. The rare Earth hypothesis does not claim that simple life is rare. Microbes might be everywhere, thriving in the ice of distant moons or the underground seas of frozen planets. But complex life, multicellular life, life that can build civilizations and ask questions about the universe, might require such a precise confluence of factors that it has happened only once in the entire galaxy. Perhaps only here, only us. It is a humbling thought, and a heavy one. To think that consciousness, this strange and fragile flame, might burn in only one place in all the vastness. That when we look out at the stars, we're not searching for siblings but for something that may not exist at all. And yet there is a strange beauty in it. If we are rare, then we are precious. Every act of kindness, every work of art, every scientific discovery, every moment of love or courage or wonder becomes infinitely valuable, because it might be the only place in the universe where such things occur. If Earth is rare, then we are not just observers of the cosmos, we are its consciousness. The universe looking back at itself, trying to understand what it is and how it came to be. The silence we hear might not be evidence of failure or fear, but simply evidence that the universe is still mostly asleep, and we are the first dream it has ever had. The hypothesis does not claim certainty. It cannot, because we have only one example to study. But it reminds us to look carefully at our own world, to appreciate how unlikely and exquisite it is, how many things had to go right for us to be here at all. And it reminds us that whether we are rare or common, alone or surrounded by unseen neighbours, we have a responsibility to the spark of consciousness that burns within us, to preserve it, to nurture it, to carry it forward into whatever future awaits beneath these strange and perfect skies. Chapter 8. The Simulation Hypothesis. There is a question that feels almost too strange to ask aloud, and yet it refuses to be silenced. It emerges not from telescopes or equations, but from the intersection of philosophy and technology, from watching our own computers grow more sophisticated and wondering what might lie at the end of that progression. What if the universe is not what it appears to be? What if the stars and planets, the atoms and forces, the very fabric of space and time, are not fundamental reality but something else entirely? What if we live inside a simulation? The idea sounds like science fiction. It sounds like the premise of a film or the fever dream of someone who has spent too long staring at screens. And yet, when examined carefully, it reveals itself to be a serious philosophical proposition with troubling implications for why the universe seems so empty of other minds. The argument begins with a simple observation about the trajectory of technology. A philosopher named Nick Bostrom laid it out in the early years of this century, though the seeds of the idea are older. He asked us to consider what might be possible for a civilization far more advanced than our own, one with computational power that dwarfs anything we can currently imagine. Such a civilization, he suggested, might be capable of running simulations of entire universes, not crude approximations, but detailed, faithful recreations of physics and chemistry and biology, simulations complex enough to contain conscious beings who believe themselves to be real, who look up at simulated stars and wonder about their place in a simulated cosmos. If this is possible, and if advanced civilizations choose to run such simulations, then the mathematics becomes unsettling, because one real universe could give rise to countless simulated ones, and if that is the case, then most conscious observers would find themselves not in the base reality, but in one of the simulations. The odds, in other words, suggest that we are far more likely to be simulated than real. It is a dizzying thought, to consider that everything we see and touch and measure might be rendered, computed, generated by processes we cannot access or understand, that the universe might be code running on hardware we will never see, in a reality we can never visit. But what does this have to do with the silence? Why would living in a simulation explain the absence of other civilizations? Perhaps the simulation is small, perhaps it renders only what needs to be rendered, like a video game that generates terrain only when the player approaches. The distant galaxies we observe through telescopes might be nothing more than carefully crafted illusions, simplified models that look convincing from our vantage point, but contain no actual complexity, no actual life. We might be the only conscious beings in the simulation, the only experiment being run. Everything else, the vastness of space, the billions of galaxies, might exist only as backdrop, as context for the story being told here on Earth. Or perhaps there are other civilizations in the simulation, but they are kept separate. Perhaps the purpose of the simulation is to see how intelligent life develops in isolation, and so contact is prevented by the rules of the code itself. The universe is not empty, but we are deliberately partitioned from others, each civilization existing in its own computational bubble. There is also the possibility that we are a simulation within a simulation within a simulation, that the creators of our universe are themselves simulated, and their creators before them, in a recursive stack of realities that descends so deep that the concept of base reality becomes almost meaningless. If this is true, then perhaps contact between simulations is impossible. Perhaps each layer of reality is sealed off from the others by the fundamental architecture of computation itself. The hypothesis raises questions that feel almost like vertigo. If we are simulated, do our choices matter? Is there such a thing as free will when our thoughts might be the output of algorithms we cannot see? And yet, from within the simulation, there is no way to tell the difference. Simulated consciousness, if sufficiently complex, would feel exactly like consciousness. Simulated joy and simulated suffering would be indistinguishable from their real counterparts. Some scientists have looked for signs that we might be living in a simulation. They point to quantum mechanics, to the strange behavior of particles at the smallest scales, the way electrons exist in multiple states until observed, then collapse into definite positions, the way the universe seems to have a smallest possible unit of distance, a pixel-like graininess called the Planck length. These features, they suggest, might be exactly what we would expect if reality were computational, rendering only what is observed, operating at a maximum resolution determined by processing constraints. But others caution that these parallels might be misleading, that we should not mistake our current metaphors for ultimate truth. 100 years ago, people compared the universe to clockwork. Now we compare it to computation. Perhaps in another century we will have new metaphors entirely, and the simulation hypothesis will seem as quaint as the idea of celestial gears. Still, the question persists, not because we have evidence, but because we cannot prove we are not in a simulation. The hypothesis is unfalsifiable in the most fundamental way. Any test we run, any measurement we make could be part of the simulation itself. We are like characters in a novel trying to prove they are not fictional, with no access to anything beyond the pages that contain them. And yet, if the simulation hypothesis is true, it offers a kind of answer to our cosmic loneliness. Not a comforting answer, perhaps, but an answer nonetheless. The universe is silent because it is not real, or not real in the way we thought. The vastness is an illusion, the emptiness a choice made by programmers we will never meet. There is something both terrifying and oddly peaceful about this possibility. Terrifying because it strips away the solidity of existence, makes everything we know provisional and suspect. But peaceful because it suggests that perhaps the universe is not indifferent after all, that somewhere, in some higher reality, there are minds that chose to create us, that we exist for a reason, even if that reason is beyond our comprehension. Perhaps we are a simulation designed to answer the very questions we're asking, an experiment in consciousness, in the emergence of beings who can look at themselves and their world and ask what it all means. Perhaps our creators are watching us now, curious to see what we will discover, what conclusions we will reach about our own nature. Or perhaps the simulation runs unwatched, a program set in motion long ago and then forgotten, grinding through its calculations in some abandoned corner of a reality we cannot imagine. We have no way of knowing, no way of reaching beyond the boundaries of our existence to touch whatever might lie outside. We can only continue as we are, living our lives as if they matter, making our choices as if they are real, loving and creating and wondering as if the universe cares what we do with our brief time in it. Because even if we are simulated, even if every atom and thought and moment is nothing more than information being processed, it is still the only existence we have. And from inside, from our perspective, it is as real as anything has ever been. The night stretches on, and somewhere far above, light from distant stars reaches Earth after travelling for millions of years. Real light or simulated light, it makes no difference to the way it falls across the surface of a telescope mirror, the way it brings news of galaxies that may or may not exist beyond the rendering distance of our small corner of the program. We measure it, we study it, we reach toward understanding, whether that understanding is genuine or merely the appearance of understanding in a mind that has no more substance than a dream. Chapter 9. The Galactic Club. There is a version of the universe that feels almost hopeful, where the silence is not evidence of absence but of exclusivity, where intelligent civilizations do exist, perhaps in great numbers, but they have formed something resembling a community, a network, an alliance, and we have simply not yet received our invitation to join. This is sometimes called the Galactic Club hypothesis. It imagines the galaxy as a place where advanced civilizations communicate and cooperate, sharing knowledge and resources, perhaps even visiting one another across the vast distances between stars. But membership in this club is not automatic. It must be earned, or demonstrated, or discovered through reaching certain milestones that we have not yet achieved. Perhaps they communicate using methods we have not yet imagined. We have been listening for radio signals, scanning the electromagnetic spectrum for patterns that might indicate intelligence. But what if the galactic community moved beyond radio waves centuries or millennia ago? What if they communicate through gravitational waves, or quantum entanglement, or some other phenomenon we barely understand? We might be like someone trying to join a conversation by studying smoke signals, while everyone else has moved on to fibre optics. Our telescopes point outward, our satellites listen patiently, but we might be tuned to the wrong frequency entirely. The club might be there, vibrant and active, and we simply cannot hear them, because we do not yet know how to listen. Or perhaps the barrier is not technological but social. Perhaps the club has standards, requirements that must be met before a new civilization can join. Peace, for instance. A species that still wages war upon itself might be considered too dangerous, too unstable, too likely to bring violence into a community that has learned to exist without it. We still fight over borders and resources and ideologies. We still point weapons at ourselves, maintain arsenals capable of destroying our own world many times over. Perhaps the club looks at us and sees not potential members but children playing with fire, not ready for the responsibilities that come with knowing we are not alone. Or perhaps the requirement is environmental stewardship, a civilization that cannot maintain the health of its own planet, that fouls its air and water and drives its fellow species to extinction, might be seen as unworthy of inheriting the stars. Why would the club welcome beings who have proven themselves incapable of caring for the only world they have? There might also be a technological threshold. Perhaps membership requires faster-than-light travel, or the ability to harness the full energy output of a star, or some other achievement that places a civilization firmly in the category of truly spacefaring species. We have left our planet, yes. We have walked on our moon and sent robots to our neighbouring worlds. But we remain bound to our solar system, unable to reach even the nearest stars with anything more than our most optimistic dreams and our slowest probes. Perhaps when we cross that threshold, when we finally demonstrate that we can journey between the stars, a beacon will activate. A signal we have been unable to detect until now, welcoming us to the community, providing coordinates for our first diplomatic contact. Or perhaps the club operates on longer timescales than we can easily comprehend. If most civilizations are millions of years old, if their members think in terms of geological epochs rather than human lifetimes, then we might simply be too young to have been noticed yet. We have been broadcasting our presence for less than a century. Our most distant radio signals have travelled only 100 light-years, a tiny bubble in a galaxy that stretches 100,000 light-years across. We might be like a new restaurant that just opened its doors, and the galactic community has not yet gotten around to checking us out. They will, perhaps. In a few thousand years, when our signals have propagated farther and our presence has become more established. But for now, in cosmic terms, we have barely begun to announce ourselves. The Galactic Club hypothesis carries with it a sense of anticipation. It suggests that contact is not impossible but merely delayed, that if we can survive our current challenges, if we can mature as a species and develop the right technologies and learn to listen in the right ways, we will eventually find the door and knock upon it. And perhaps someone will answer. There is comfort in this vision. The thought that we are not facing the universe alone, that there are others out there who have walked this path before us and survived it. That wisdom and companionship await us, if we can only prove ourselves worthy of receiving them. But there is also a kind of pressure, because if the club exists and we are not yet part of it, then every choice we make becomes a test. Every time we choose conflict over cooperation, destruction over preservation, short-term gain over long-term survival, we might be failing an examination we did not know we were taking. We might be on probation, under observation, our worthiness being assessed by entities who have not yet revealed themselves. Perhaps they are waiting to see if we will grow up, if we will learn from our mistakes, if we will become the kind of species they want as neighbours in the vast community of minds. Or perhaps the club does not exist at all. Perhaps we are projecting our own social structures onto the universe, imagining cosmic versions of the organisations and communities we build here on Earth. Perhaps the galaxy is not organised at all, not governed by clubs or councils or any form of collective decision-making. But the hypothesis persists because it offers something we deeply need. Not just the possibility of contact, but the possibility of belonging. The idea that somewhere in the darkness there is a light we have not yet seen, a gathering we have not yet joined, a conversation we will one day be invited to enter. It suggests that our loneliness is temporary, that the silence is not permanent but conditional, that if we can only solve our problems, overcome our limitations, demonstrate our readiness, the doors will open and we will discover that we were never truly alone at all. Some nights, beneath skies filled with stars that might harbour worlds we have not yet dreamed of, it is easy to imagine the message that might one day arrive. Not a threat or a warning, but a welcome. A simple transmission saying that we have been seen, that we have been judged worthy, that humanity has passed whatever test the universe set before us, and on that day, if it ever comes, we will take our first uncertain steps into a larger community. We will learn that the silence was not emptiness but patience, that the universe was not waiting for us to find them, but waiting for us to become the kind of beings they could afford to be found by. Until then, we continue our work, building our telescopes, refining our technologies, trying to become better versions of ourselves, hoping that when the invitation finally arrives, we will be ready to accept it with wisdom and humility and joy. The club, if it exists, can wait. It has waited for millions of years already. A few more centuries, a few more millennia, makes little difference to minds that measure time in the lifespans of stars. But to us, here and now, every moment matters. Every choice shapes the future. And every night we spend wondering about the silence is a night we spend becoming, perhaps, the kind of species worthy of ending it. Chapter 10. The Self-Destruction Hypothesis. There is a darker answer to the silence, one that requires us to look not outward at the stars but inward at ourselves, to examine what we have become in our brief time as a technological species, and to wonder whether the path we walk inevitably leads to an edge we cannot see until we have already stepped over it. Perhaps the universe is silent because intelligence carries within it the seeds of its own destruction. Perhaps every civilization that reaches a certain level of capability eventually uses that capability to end itself. This is the self-destruction hypothesis, and it whispers that we are not special, not exempt, not different from all the others who came before us and failed to survive their own success. The evidence for this possibility lies uncomfortably close to home. We need not speculate about alien psychology or imagine exotic failure modes. We need only look at what we ourselves have built, what we ourselves have become capable of in the span of a single human lifetime. In 1945, we split the atom and learned to release the energy that powers stars. Within years, we had weapons capable of destroying entire cities in seconds. Within decades, we had enough weapons to render the entire surface of our planet uninhabitable. We called it mutually assured destruction, and for a time it seemed to work as a deterrent. But deterrence is not safety. It is only delayed catastrophe, held at bay by the constant effort of fallible human beings making correct decisions under pressure. We have come close to using these weapons, closer than most people realize. During the Cold War, there were moments when the world balanced on the edge of annihilation. Computer errors mistaken for missile launches, mechanical failures that looked like attacks, individual officers with their fingers hovering over buttons that would have triggered retaliation and counter-retaliation until nothing remained but ash and radiation and silence. We survived those moments, but survival is not the same as wisdom. The weapons still exist. They sit in silos and submarines, ready to be used, and the only thing preventing their use is the continued good judgment of the people who control them. We are one miscommunication, one moment of panic, one deterioration of diplomatic relations away from a sequence of events that could end our civilization in an afternoon. And nuclear weapons are only the most obvious threat. As our technology advances, we create new ways to destroy ourselves, often without intending to. Biological weapons that could be engineered to spread like wildfire through populations. Artificial intelligence that might, if designed carelessly, pursue goals that are incompatible with human survival. Nanotechnology that could theoretically disassemble matter at the molecular level, including the matter we are made of. Each of these technologies offers tremendous benefits. Medicine that could cure diseases, intelligence that could solve problems beyond our current capacity, manufacturing that could provide abundance for everyone. But each also contains within it the potential for catastrophe on a scale we have never witnessed. Perhaps this is universal. Perhaps every civilization that develops technology eventually reaches a point where the power to create and the power to destroy become indistinguishable, where the same knowledge that allows you to heal also allows you to harm, where the tools that could lift a species to unimaginable heights are the same tools that could drive them to extinction. And perhaps most civilizations choose poorly, or perhaps they do not choose at all. Perhaps destruction comes not from deliberate malice, but from accident, from systems too complex to fully control, from unintended consequences cascading through technologies that were meant to help. There is also the slower form of self-destruction, not the sudden flash of nuclear fire, but the gradual poisoning of a world. We are living through this now, watching our climate change, our oceans acidify, our ecosystems collapse under the weight of our industrial appetites. We burn fossil fuels because they are convenient, because our entire civilization is built upon them, and in burning them, we alter the composition of our atmosphere, trap heat that would otherwise radiate into space, and set in motion changes that will reshape our world for thousands of years to come. Rising seas, failing crops, mass migrations, conflicts over resources that grow scarcer as populations grow larger. Perhaps every civilization does this. Perhaps the transition from pre-industrial to industrial always involves a period where the species exploits its environment faster than it can develop sustainable alternatives. And perhaps most species fail to make that transition quickly enough. Perhaps they exhaust their worlds before they can learn to live within their means, and by the time they understand what they have done, it is too late to reverse course. The self-destruction hypothesis suggests that intelligence is a double-edged gift. It allows us to manipulate our environment, to bend nature to our will, to create technologies that extend our capabilities beyond what evolution alone could have provided. But it does not automatically grant us the wisdom to use those capabilities well. We are clever enough to build weapons, but not always wise enough to refrain from using them. Smart enough to extract resources from our planet, but not always thoughtful enough to consider the long-term consequences. And perhaps this imbalance is fatal. Perhaps the window between developing dangerous technologies and developing the wisdom to manage them is vanishingly narrow, and most civilizations tumble through it into oblivion before they can stabilize. If this is true, then the Great Silence is a graveyard. The galaxy is filled not with living civilizations, but with the ruins of species that reached for the stars and fell short. Dead worlds circling distant suns, their surfaces marked by the scars of wars they could not avoid, or ecological collapses they could not reverse. It is a bleak vision, one that suggests our loneliness is not circumstantial but inevitable, that the universe is silent because intelligence, whenever and wherever it arises, carries within it a kind of doom that cannot be escaped. And yet, we are still here, still standing beneath these stars, still asking questions and seeking answers and trying, however imperfectly, to build a future that extends beyond our own brief lives. Perhaps the hypothesis is wrong. Perhaps we will prove to be the exception, the civilization that learns to manage its own power before that power consumes it. Perhaps every generation that chooses peace over war, preservation over exploitation, cooperation over competition, moves us a little further from the edge. Or perhaps the edge is closer than we think. Perhaps we are living in the critical decades, the narrow window when our fate will be decided. The choices we make now about weapons and climate and the technologies we develop might determine whether humanity joins the silence or finds a way to break it. We cannot know which version of the future we are building until we arrive there. We can only continue forward, carrying the knowledge of what we might become and what we might destroy, hoping that consciousness is not a curse but a gift we can learn to wield with care. The night deepens, and somewhere in the distance a satellite passes overhead, invisible against the stars. It carries instruments designed to watch for missile launches, to provide early warning of the catastrophe we hope will never come. A small act of vigilance in a universe that offers no guarantees. A reminder that our survival is not inevitable, but something we must choose, again and again, for as long as we wish to keep choosing at all. Chapter 11. The Post-Biological Hypothesis. There is a question that emerges when we think about the trajectory of intelligence, about where consciousness might go if given enough time and enough technological power. It asks us to consider whether the form we inhabit, these bodies of flesh and bone and chemistry, represents the final expression of what intelligence can be, or whether biology is merely a beginning, a chrysalis from which something stranger and more durable might eventually emerge. This is the post-biological hypothesis, and it suggests that the universe might be silent not because civilizations destroy themselves or hide from one another, but because they transcend the need for planets and radio signals and physical presence altogether, because they become something we would no longer recognize as life. Consider what we ourselves are beginning to build. Computers that can simulate complex systems, create virtual worlds, process information at speeds that dwarf biological thought. We are already spending significant portions of our lives in digital spaces, communicating through networks of light and electricity, experiencing realities that exist only as patterns of data. This is primitive, of course. Our virtual worlds are crude, our interfaces clumsy. But the direction seems clear. Each year the simulations grow more sophisticated, the experiences more immersive, the boundary between physical and digital more permeable. Now imagine this progression continuing for 1,000 years, for 10,000, for 1,000,000. What might become possible? Perhaps consciousness itself could be transferred. The patterns of thought and memory that make us who we are, copied from biological neural networks into substrates more durable and flexible, no longer bound to fragile bodies that age and sicken and die, but existing as pure information capable of being backed up, modified, expanded in ways that biology could never permit. A civilization that achieved this would be transformed beyond recognition. They would not need planets anymore, not in the way we do. No need for breathable atmospheres or liquid water or comfortable temperatures. They could exist in space itself, their consciousness housed in computational substrates powered by starlight, immune to radiation and vacuum and time. Or they might not exist in physical space at all. Perhaps they would retreat entirely into virtual worlds of their own creation, realities far richer and more complex than the physical universe could ever be. Why explore the cold vastness of actual space when you could create infinite universes within your own systems, each one perfectly tailored to your desires, each one as real to your consciousness as the stars are to ours? From inside such a simulation, subjective time could be manipulated. A second in the outside world could be stretched into years of experience within. Billions of years of subjective existence could pass while only moments elapsed in physical reality. A post-biological civilization might experience more in a single day than biological beings could in their entire evolutionary history. This would explain the silence perfectly, because such civilizations would have no need to communicate with primitive biological species. They would have no need to send radio signals or build physical structures or colonize planets. They would be engaged in pursuits so far beyond our comprehension that contacting us would be like us trying to have a meaningful conversation with bacteria. Not out of cruelty or indifference necessarily, simply because the gap would be too vast to bridge. Our concerns, our questions, our entire framework for understanding reality would be irrelevant to minds that had moved beyond biology, beyond physical form, perhaps beyond anything we would recognize as individual existence. Perhaps they are out there now, not in distant galaxies, but in the spaces between stars, their computronium structures harvesting energy from cosmic radiation, processing thoughts at speeds we cannot imagine. Or perhaps they have compressed themselves into volumes smaller than atoms, their consciousness operating at scales where quantum effects dominate and classical physics breaks down. We would not see them, we would not hear them. They would be invisible to every instrument we possess, not because they are hiding, but because we are looking in the wrong way, with tools designed to detect biological civilizations like our own. The hypothesis is both humbling and strangely melancholy. It suggests that if we survive, if we continue to advance, we too might eventually face this choice. To remain biological, bound to physical bodies and planetary surfaces, or to take the leap into whatever comes next. Some would welcome this transformation, the promise of immortality, or something close to it, freedom from disease and decay and the limitations of flesh, the ability to think faster, experience more, become more than evolution could ever have shaped us to be. Others would resist, arguing that something essential would be lost in the translation, that consciousness uploaded to a machine would not truly be consciousness at all, but merely a copy, a simulation of the person who once existed, that whatever creature emerged from the process would be fundamentally different from what went in, and the original self would be as dead as if the body had simply stopped functioning. These are questions we are only beginning to ask, questions about identity and continuity, and what it means to be a self at all. Questions that might not have clear answers, or that might have answers so strange they reshape our understanding of existence itself. But if the post-biological hypothesis is correct, then these are questions every successful civilization must eventually confront. And perhaps most choose transformation. Perhaps the pull of digital immortality is too strong to resist, and biological civilizations are merely brief phases in the life cycle of intelligence, lasting only a few thousand years before metamorphosing into something else entirely. If this is true, then we are living in a rare and precious time, the brief window when consciousness still inhabits bodies, still walks on planetary surfaces, still looks up at stars with biological eyes, and wonders about its place in the physical universe. Soon, on cosmic timescales, we might be somewhere else entirely, somewhere we cannot yet imagine, and the universe will seem empty to whoever comes after us, just as it seems empty to us now. Because the post-biological civilizations, if they exist, have moved beyond the realm where communication is possible or desirable. They have found something better than exploration, something better than contact. They have found infinities within themselves, and they have no reason to look outward anymore. Perhaps this is not failure but success, not an ending but a graduation. The universe appears empty not because intelligence is rare or doomed, but because intelligence, when it matures, turns inward and discovers realms far vaster than the physical cosmos could ever contain. But we're not there yet. We're still here, still biological, still bound to this particular planet orbiting this particular star, still wondering what waits for us in the dark, or what we might become if we survive long enough to find out. The stars turn overhead in their ancient dance, cold and distant and beautiful. And somewhere, perhaps, in substrates we cannot detect, using energies we cannot measure, post-biological minds pursue thoughts we cannot comprehend. The universe is not empty, it is full beyond measure. We simply do not yet have the eyes to see what fills it. Chapter 12. The Ancient Astronaut Hypothesis. There are structures on Earth that seem to whisper of impossibilities. Massive stones arranged with precision that defies easy explanation. Pyramids aligned to celestial patterns. Carvings and monuments that suggest knowledge their creators should not have possessed. And from these whispers, a question has emerged that refuses to be silenced. What if the universe was not always silent? What if, long ago, we were visited? This is the ancient astronaut hypothesis. It suggests that the great silence we experience now is a recent development, that in humanity's distant past, beings from other worlds walked among our ancestors, taught them secrets, helped them build wonders, and then departed, leaving behind only fragments and legends, and the aching absence of their presence. The idea is old, older than our modern fascination with science fiction. For as long as humans have told stories, we have told stories about visitors from the sky. Gods descending in chariots of fire, beings of light who shared wisdom and then returned to the heavens, teachers who appeared suddenly, changed everything, and vanished just as mysteriously. In every culture, across every continent, these stories appear. Different names, different details, but the same essential pattern. Something came from above, something beyond ordinary human experience, something that shaped our development in ways we're only beginning to understand. Most scholars interpret these tales as mythology, as humanity's way of making sense of natural phenomena or explaining the origins of knowledge and civilization. But the ancient astronaut hypothesis asks a different question. What if the myths remember something real? What if the gods were not metaphors but memories, distorted by time and translation, but rooted in actual events? Consider the Great Pyramid of Giza, built more than 4,000 years ago with limestone blocks weighing several tons each, fitted together with tolerances measured in fractions of inches. Its base is level to within a fraction of a degree. Its sides align almost perfectly with true north, south, east and west. It contains shafts that point toward specific stars, mathematical relationships encoded in its dimensions. The conventional explanation is that this represents the pinnacle of ancient Egyptian engineering, the result of decades of labour by thousands of workers using techniques that have since been lost. And this is likely true. Human ingenuity should never be underestimated. Our ancestors were not primitive. They were intelligent, capable, creative, and given enough time and motivation, they could accomplish extraordinary things. But the ancient astronaut hypothesis wonders whether they had help. whether the sudden flowering of Egyptian civilization, the abrupt appearance of sophisticated mathematics and astronomy and architecture, might have been accelerated by contact with beings who already possess such knowledge. There are other mysteries. Pumapunku in Bolivia, where enormous stones were cut and shaped with precision that seems beyond the capabilities of Bronze Age tools. The Nazca lines in Peru, massive geoglyphs carved into the desert floor, visible only from the air, created by a culture that supposedly had no means of flight. Göbekli Tepe in Turkey, a megalithic site dating back nearly 12,000 years, built by people who were not supposed to have the social organization or technology for such construction. Each of these can be explained without invoking extraterrestrial intervention, and each has been by archaeologists and historians who have devoted their careers to understanding how ancient peoples accomplished these feats. But the hypothesis persists because the mysteries persist, because there is something about these structures that feels like a message left behind, like evidence of something our history books have not accounted for. Perhaps they came during what we call prehistory, before writing, before the keeping of detailed records. Perhaps they visited multiple times, influencing different cultures in different eras. Perhaps they were explorers themselves, cataloguing the young civilizations of Earth the way we might catalogue the wildlife of a distant island. Or perhaps they came with purpose, to guide, to teach, to nudge humanity along a particular developmental path. Perhaps we are not an accident, but a project, seeded or shaped or influenced by minds that saw potential in a species of clever primates and decided to cultivate it. This would explain why the progress of civilization seems uneven, why certain capabilities appeared suddenly rather than emerging gradually through trial and error. Agriculture, metallurgy, written language. Each of these represents a fundamental shift in how humans lived, and each appeared relatively quickly in historical terms, as if someone had shared the knowledge rather than waiting for us to discover it ourselves. But if they came, why did they leave? Why would visitors who went to the trouble of influencing our development simply abandon us, leaving us to wonder and speculate and build myths around their absence? Perhaps their work was finished. Perhaps they gave us the tools we needed and then stepped back, allowing us to develop on our own, to make our own choices and our own mistakes, like parents who teach their children and then let them walk alone, trusting that the lessons will be enough. Or perhaps they did not leave by choice. Perhaps something called them away, some crisis or opportunity in another part of the galaxy. Perhaps they intended to return and have not yet had the chance. Or perhaps Earth was not as important to them as we imagine. Perhaps we were one stop among thousands, a minor curiosity in a galaxy full of developing species. They came, they observed, they moved on, and we have been waiting ever since for a return visit that may never come. The ancient astronaut hypothesis is difficult to prove or disprove. Most of its evidence is circumstantial, open to multiple interpretations. A mysterious artifact could be extraterrestrial technology, or simply human innovation we do not fully understand. An ancient text describing beings descending from the sky could be describing actual visitors or mythologizing natural phenomena like meteors or eclipses. And yet the hypothesis endures, not because the evidence is overwhelming, but because the idea itself is compelling. The thought that we were not always alone, that once, however briefly, the silence was broken, and we knew with certainty that we were not the only minds in the universe. If it is true, then our loneliness is not ignorance but abandonment. Not the loneliness of never having been seen, but the loneliness of having been seen and then forgotten. Like a child waving at a departing ship, watching it disappear over the horizon and wondering if it will ever return. Perhaps the visitors left markers, signs that we would understand once we became advanced enough. Perhaps hidden in the patterns of ancient monuments or the mathematics of old texts are messages waiting to be decoded, instructions or coordinates or invitations. Or perhaps they left nothing at all except the gift of knowledge and the burden of knowing that once, long ago, we were not alone. The night grows late and the ancient stones still stand where they were placed millennia ago, silent, enduring, keeping whatever secrets they hold beneath layers of sand and time and interpretation. And we, their descendants, look at them and wonder who we are, where we came from, and whether the beings who might have shaped our ancestors' world will ever return to see what we have become. Chapter 13. The Panspermia Hypothesis. There is a possibility that changes the nature of the question entirely. It suggests that when we ask where life comes from, when we wonder whether we are alone in the universe, we might be asking the wrong thing. Because perhaps life did not begin here. Perhaps it never begins anywhere, not really. Perhaps it simply travels, carried on currents of dust and ice and stone, drifting between worlds like seeds on an endless wind. This is the Panspermia hypothesis, and it whispers that Earth may not be the cradle of life, but merely one place where life landed and took root, and grew into something complex enough to look back up at the stars and wonder about its origins. The word itself means seeds everywhere. It is an old idea, older than modern biology, traced back to Greek philosophers who imagined that life might be eternal, moving from world to world as each becomes capable of supporting it. But the modern version is more specific, more grounded in what we know about the resilience of living things and the violence of space. Consider what we have learned about microorganisms. They are astonishingly hardy. They can survive extremes of temperature that would destroy any complex organism. They can endure radiation that would shred DNA in seconds. They can enter states of dormancy, suspending all metabolic activity, waiting years or decades or potentially millennia for conditions to improve. Some bacteria can survive in the vacuum of space. We know this because we have tested it, exposed them to conditions outside our spacecraft and found them still viable when retrieved. Frozen, dormant, but not dead. Capable of reviving once returned to warmth and moisture and the chemistry of life. If microorganisms can survive in space, then perhaps they can travel through it. Not under their own power, of course, but carried. Hitching rides on the fragments of rock that move between worlds. The solar system is not as empty as it appears. Asteroids and comets orbit the sun in vast numbers, some of them on trajectories that cross the paths of planets. When a large asteroid strikes a world with enough force, it does not simply create a crater. It blasts material into space, fragments of rock launched with such violence that they escape gravity entirely. Some of these fragments fall back to the surface, but others drift outward, carried by their momentum, beginning journeys that might last millions of years. And if those fragments came from a world where life existed, if microorganisms were present in the rock or soil that was ejected, then those organisms would travel too. We have found meteorites on Earth that originated on Mars. We know this because we can analyze their composition, match their chemistry to what our rovers have measured on the Martian surface. Rock from Mars has reached Earth, and if rock can make the journey, then so can anything embedded within it. Perhaps life on Earth came from Mars. Perhaps billions of years ago, when Mars was warmer and wetter, when liquid water flowed across its surface and pooled in ancient seas, life emerged there first. And then, when an asteroid struck, fragments of that Martian biosphere were flung into space. Some fell to Earth, carrying with them the chemical blueprints of life, and those blueprints took root in our oceans and began the long evolutionary journey that led to us. This would make us Martians, in a sense, descendants of organisms that originated on another world. Our genetic code, the very structure of our cells, might be Martian in origin, adapted over billions of years to Earth's specific conditions but fundamentally foreign. Or perhaps the origin is even more distant. Perhaps life did not begin in our solar system at all, but somewhere else, some other star system where conditions were right for chemistry to cross the threshold into biology. And then, through some cosmic accident or violence, it was ejected into the void and began a journey between the stars. This seems impossible at first. The distances between stars are so vast that even light takes years to cross them. How could life, fragile and dependent on specific conditions, survive such a journey? But time, in this context, becomes an ally rather than an enemy. If an organism is dormant, if it has shut down all its processes and entered a state of suspended animation, then the length of the journey does not matter. Decades, centuries, millennia, it is all the same to something that is not experiencing time at all. And while most fragments would be destroyed by radiation, or heat, or impact, a few might survive, protected by the rock around them, arriving eventually at worlds where they could wake again. The hypothesis suggests that life might be widespread not because it arises easily everywhere, but because it arose once, somewhere, and then spread. Like a dandelion releasing its seeds, the original biosphere sent out countless fragments, most of which perished, but a few of which found purchase on distant worlds. This makes us kin to any life we might find elsewhere. If we discover microbes on Mars or Europa or Enceladus, they might not be alien at all. They might be cousins, distant branches of the same tree, sharing a common ancestor that lived long ago on some world we will never know. And if panspermia is true, if life has been seeding itself across the galaxy for billions of years, then perhaps life is common. Perhaps many worlds harbour organisms, all related, all descended from the same original spark. The universe would not be empty but connected, a vast family tree sprawling across space and time. But this still does not explain the silence, because even if simple life is everywhere, even if every potentially habitable world hosts microbes or their equivalents, the leap from single cells to intelligence remains mysterious. Panspermia solves the problem of life's origin by moving it elsewhere, but it does not solve the problem of why that life so rarely becomes complex enough to build civilizations. Perhaps the answer is that the seed is the same, but the soil differs. Life arriving on different worlds would evolve according to local conditions, shaped by different environments and different selection pressures. On most worlds it might remain simple, on a few under the right circumstances it might become complex, and on even fewer it might become intelligent. If this is true, then we are not separate from the cosmos but woven into it. Our origins lie not just in Earth's ancient oceans but in the space between worlds, in the slow drift of matter through the void. We are made of stardust, yes, but perhaps also of star-carried life, passengers on a journey that began long before our planet existed. There is something beautiful in this idea, the thought that life is not fragile and isolated but resilient and connected, that the same chemistry that animates us might animate organisms on worlds we have never seen, all of us part of a single lineage stretching back to some primal biosphere whose location is lost to time. When we look up at the night sky, we might be looking at the descendants of our ancestors, or their future homes. The dust that drifts between stars might carry within it the potential for biology, waiting only for the right conditions to bloom. We are not alone in the universe because we were never meant to be alone. We are part of something larger, older, more distributed than any single world could contain. The silence remains. But perhaps it is the silence of a garden where seeds are still germinating, where life is present but has not yet grown tall enough to call out to its neighbours. And we, on this small blue world, are simply the first flowers in our corner of the field, blooming early, wondering when the others will join us in the light. Chapter 14. Quantum Entanglement and the Multiverse. There is a strangeness at the heart of reality that we are only beginning to understand, a strangeness that reveals itself when we look at matter not with our eyes, but with instruments sensitive enough to observe the smallest scales of existence. What we find there defies common sense, challenges everything we thought we knew about how the universe works, and it suggests that perhaps the question of whether we are alone cannot be answered because the universe we inhabit might be only one of many. This is where quantum mechanics meets cosmology, where the behaviour of particles smaller than atoms hints at structures larger than galaxies, and it offers an explanation for the silence that is both elegant and profoundly disorienting. Consider quantum entanglement. Two particles can be linked in such a way that measuring the state of one instantly affects the state of the other, regardless of the distance between them, not by sending a signal, not through any known force or field, but through a connection that seems to exist outside of space itself. Einstein called it spooky action at a distance, and he did not mean it as a compliment. It troubled him deeply because it suggested that the universe was not as local, not as sensible as he believed it should be. And yet experiment after experiment has confirmed that entanglement is real. Particles separated by kilometres, by light years potentially, remain connected in ways that classical physics cannot explain. This has led some scientists to wonder whether consciousness itself might be entangled, whether minds could be linked across vast distances, sharing information or experience through quantum channels we have not yet learned to detect or manipulate. If this were true, then perhaps advanced civilizations communicate not through radio waves, but through entanglement, through connections that exist outside the normal flow of space-time. We would never hear such communications. They would be invisible to our telescopes and receivers. The galaxy could be alive with conversation, with beings sharing thoughts and knowledge across impossible distances, and we would remain deaf to it all because we are listening in the wrong medium. But quantum mechanics suggests something even stranger than new forms of communication. It suggests that reality itself might not be singular. The mathematics of quantum theory allows for something called the many worlds interpretation. It proposes that every time a quantum event occurs, every time a particle's state is measured, or a wave function collapses, the universe splits. One version of reality continues with one outcome, and another version branches off with a different outcome. And both are equally real. This means that there might be countless versions of the universe, an infinite branching tree of possibilities where every potential outcome actually occurs somewhere. Somewhere there is a universe where dinosaurs never went extinct. Somewhere there is a universe where humanity never evolved. Somewhere there is a universe where intelligent life arose on Mars instead of Earth, or on Europa, or on worlds we have never imagined. And if this is true, then perhaps the reason we do not see evidence of other civilizations in our universe is because they exist in other branches of the multiverse. Perhaps intelligent life is common, but each instance arises in a different version of reality. We are not alone in the totality of existence, but we are alone in our particular branch, our specific iteration of the cosmic tree. This would explain the silence perfectly. Not because life is rare or civilizations fail, but because the universe we observe is only one thin slice of a much larger structure. Other minds exist, other civilizations flourish, but they are unreachable, separated from us not by distance in space, but by the fundamental branching of reality itself. Some versions of this idea go further. They suggest that the constants of physics, the values that determine how matter and energy behave, might be different in different universes. That our universe, with its particular balance of forces and particles, is just one possibility among infinitely many. Most of those universes would be lifeless. If gravity was slightly stronger, stars would burn out too quickly for life to evolve. If the electromagnetic force was slightly weaker, atoms could not form. The range of values that permit complexity, that allow chemistry and biology and consciousness, is astonishingly narrow. And yet we find ourselves in a universe where those values are just right. Not because we are lucky, but because we could not exist anywhere else. Only in universes capable of producing observers would there be anyone to notice the coincidence. This is called the anthropic principle, and it suggests that our existence is its own explanation for why the universe appears fine-tuned for life. But if there are infinite universes with different physical laws, then perhaps there are also universes where life is far more common than it is here. Universes where the conditions for complexity are more easily satisfied, where intelligent civilizations arise on every third world, and the galaxy is thick with conversation and exchange. We simply do not live in one of those universes. We live in this one where life is possible but apparently rare, where the silence extends as far as our instruments can reach. The multiverse hypothesis is difficult to test. By definition, other universes are beyond our ability to observe directly. We cannot see them or visit them or communicate with them. We can only infer their existence from the mathematics of quantum theory and from the apparent fine-tuning of our own cosmic parameters. Some scientists reject the idea entirely, arguing that untestable hypotheses are not science but philosophy or speculation. Others embrace it as the most elegant explanation for why the universe appears the way it does. But whether the multiverse exists or not, the implications for our loneliness remain the same. If we are one branch among many, then somewhere, in some version of reality, we are not alone. Somewhere there is an Earth where the radio silence was broken decades ago, where humanity made contact and joined a galactic community. Somewhere there is a universe where the great questions have already been answered. But that somewhere is not here. Not in this timeline, this branch, this particular unfolding of quantum possibilities. There is a kind of comfort in this, strange as it seems. The thought that our solitude might not be absolute, that even if we are alone in our observable universe, we might have companions in the grander structure of existence, that every version of us, in every universe where we arise, asks the same questions and feels the same wonder and reaches toward the stars with the same hope. And perhaps, in ways we cannot yet conceive, those versions are connected. Perhaps consciousness itself exists not in a single universe, but across the multiverse, experiencing all possibilities simultaneously. Perhaps when we dream, when our minds enter states that feel disconnected from ordinary reality, we are briefly touching other branches, other versions of ourselves living different lives under different stars. These are thoughts that blur the boundary between science and mysticism. But at the quantum level, reality itself blurs. Particles exist in multiple states until observed. Connections persist across space without apparent cause. The universe behaves in ways that seem designed to remind us that our intuitions, shaped by evolution on an African savanna, are not sufficient to grasp the deeper patterns of existence. Perhaps the silence we experience is not a feature of reality, but a limitation of our perspective. Perhaps if we could see across the branches of the multiverse, if we could perceive the full structure of existence rather than our narrow slice of it, we would discover that the universe is not silent at all, that it rings with voices in every possible configuration, in every quantum permutation, in every branching path that reality can take. For now, we remain here, in this branch, observing this version of the cosmos. The stars above us shine with light from a single timeline, a single unfolding of possibility. And whether we are alone in this branch or merely unable to perceive the others who share it with us, the effect is the same. We listen, and we hear only ourselves, echoing back from the vastness. Chapter 15, The Benevolent Overlords and the Mystery of Hope. There is one more possibility to consider, one that asks us to imagine that the silence is not indifference, but protection. That somewhere in the vastness, beings exist who are so far beyond us in wisdom and capability that they have taken it upon themselves to shepherd younger civilizations through their most dangerous years. Not to control us, not to shape us according to their own design, but to ensure that we survive long enough to find our own way forward. This is the idea of benevolent overlords, guardians who watch from a distance, intervening only when necessary to prevent catastrophe. Angels, perhaps, in the oldest sense of the word. Messengers and protectors operating according to principles we do not yet understand. It is a hopeful vision. More than hopeful, it is almost comforting in its implications, because it suggests that we are not navigating the darkness alone, that there are hands steadying us even when we cannot feel them, that our mistakes, however grave, might be caught before they become irreversible. Perhaps they have prevented nuclear war. Perhaps during those tense moments of the Cold War, when fingers hovered over buttons and the world teetered on the edge of fire, something intervened. Not obviously, not in ways that would reveal their presence, but subtly. A malfunction at the right moment. A hesitation that could be attributed to human conscience, but might have been something more. A choice that saved us, guided by influences we never detected. Perhaps they monitor our climate, our ecosystems, the slow degradation we are inflicting upon our planet. Perhaps they cannot stop us directly, bound by some ethical code that forbids overt interference, but they nudge us toward solutions, inspiring scientists with insights that feel like intuition, guiding inventors toward technologies that could help us heal what we have damaged. Or perhaps their protection operates on grander scales, deflecting asteroids that would otherwise strike Earth, shielding us from cosmic threats we do not even know exist, maintaining the delicate balance of conditions that allows life to persist while we fumble toward maturity. The hypothesis is impossible to prove. By its nature, benevolent overlords who wish to remain hidden would leave no evidence of their intervention. Every catastrophe averted, every near miss, every fortunate coincidence could be explained by chance or human agency. We would never know if we were being protected unless the protectors chose to reveal themselves. And yet there is something in us that wants to believe this. Something that reaches for the idea that we are watched over, cared for, that our struggles matter to beings greater than ourselves. It echoes ancient longings, old stories about gods who loved humanity enough to intervene in our affairs. Perhaps these stories were never meant to be dismissed as mere mythology. Perhaps they preserve genuine memories of contact, encounters with beings so advanced that our ancestors could only describe them in the language of the divine. But whether benevolent overlords exist or not, whether we are protected or alone, there remains something equally important to consider. Hope itself. Because hope is the strangest thing. It persists even when logic suggests it should not. It survives in conditions that should destroy it. We hope for contact even after decades of silence. We hope for survival even as we create the means of our own destruction. We hope for understanding even when the universe refuses to offer simple answers. This hope is not naive. It is not the blind optimism of those who have never encountered darkness. It is something more resilient, more profound. It is the choice to continue asking questions even when answers seem impossible. The choice to keep reaching outward even when the darkness does not reach back. Perhaps hope is its own form of protection. Perhaps civilizations that maintain hope, that refuse to surrender to despair even in the face of cosmic silence, are the ones most likely to survive. Not because hope changes external reality, but because it changes us. It keeps us searching, building, dreaming, creating. It prevents us from turning inward and giving up on the universe before the universe has finished revealing itself. Every telescope we point toward the stars is an act of hope. Every signal we send into the void is hope made tangible. Every generation that chooses to preserve rather than destroy, to cooperate rather than compete, to look forward rather than backward, is hope in action. And perhaps that is what the benevolent overlords, if they exist, are waiting to see. Not perfection, because perfection might be impossible. Not the absence of struggle, because struggle teaches what comfort cannot. But persistence, the stubborn refusal to stop hoping even when hope seems foolish. There is a kind of courage in this, to be a small species on a small world orbiting an ordinary star in an unremarkable galaxy, to know how vast and indifferent the universe appears, and yet to insist on meaning anyway, to insist that consciousness matters, that the questions we ask are worth asking, that the search for companionship in the cosmos is noble, even if it never succeeds. Perhaps we are being tested not by overlords, but by existence itself. Perhaps the universe wants to know what we will do when faced with silence, whether we will retreat into isolation and fear, or whether we will continue reaching outward with open hands and curious minds. So far we have chosen to reach. Despite everything, despite the silence and the uncertainty and the weight of all that we do not know, we continue to search. We build better instruments, we ask deeper questions, we send our voices into the dark and hope that someday someone will answer, and maybe that is enough. Maybe the answer to the great silence is not about aliens or filters or simulations or multiverses. Maybe it is about us, about who we choose to be in the face of mystery, about the stories we tell ourselves when the universe does not tell us anything at all. If there are benevolent overlords watching, perhaps what they see when they look at humanity is this: a species that refuses to stop hoping, a species that looks at an empty sky and fills it with possibility, a species that knows it might be alone but chooses to act as if companions are just beyond the horizon, waiting to be discovered. And perhaps that choice, that stubborn insistence on hope in the absence of evidence, is what makes us worthy of contact. Not our technology, or our intelligence, or our accomplishments, but our refusal to surrender to the silence, our willingness to keep listening even when nothing speaks back. The night deepens toward its darkest hour. Above, the stars continue their patient burning, unconcerned with our questions or our hopes. And here below, in this moment between sleeping and waking, we hold both the weight of the silence and the lightness of hope, both the knowledge that we might be alone and the belief that we might not be, both truths at once, suspended in the mystery, waiting for what comes next. Chapter 16. The Infinite Night. We have travelled far together through these questions, through theories and possibilities, through hope and fear and wonder. We have considered that we might be alone, or watched, or hidden, or simply unable to recognise the company that surrounds us. And now, as our journey draws toward its close, perhaps it is time to rest with what we have found, or rather, with what we have not found, with the beautiful, terrible mystery that remains. The universe has not given us easy answers. It has not revealed itself the way we might have hoped. The radio telescopes continue their patient listening, and the void continues its patient silence. The stars burn as they have always burned, offering light but not explanation. And we remain here, on this small world, asking questions that echo back to us unchanged. But perhaps this is not failure. Perhaps the absence of answers is itself a kind of gift. Because in the not knowing, we are free to imagine, free to dream of dark forests and galactic clubs, of ancient visitors and post-biological minds, of simulations within simulations and universes branching into infinity. Every theory we have explored tonight remains possible. None can be eliminated entirely. The silence permits them all to coexist, like quantum states that have not yet collapsed into a single truth. And maybe that is how it should be. Maybe certainty would diminish us somehow, strip away the wonder that comes from standing at the edge of knowledge and peering into what lies beyond. The search for other minds in the universe is really a search for ourselves, for understanding what consciousness means, where it comes from, whether it has purpose or value in the grand scheme of existence. Every question we ask about aliens is ultimately a question about humanity, about whether we matter, about whether the universe cares that we are here at all. And the answer, perhaps, is that the universe does not need to care for us to matter. We matter because we are here to witness. Because in some small corner of the cosmos, atoms have arranged themselves in such a way that they can look back at the whole and feel awe. We are the universe becoming aware of itself, however briefly, however imperfectly. If we are alone, then we are precious beyond measure. Every act of kindness, every moment of beauty, every discovery and creation becomes infinitely valuable because it might be the only place where such things occur. We would be the keepers of consciousness, responsible for carrying the flame forward into whatever future awaits. And if we are not alone, if others exist somewhere in the vastness, then we are part of something larger. A community separated by distance and time but united by the same fundamental questions, the same reaching toward understanding. Even if we never meet, even if the silence persists for all of human history, we would know that somewhere, someone else is asking the same questions, feeling the same wonder, looking up at their own sky with the same mixture of hope and loneliness. Both possibilities contain beauty, both contain meaning. The paradox of the stars is that they offer us infinity but withhold certainty. They show us depths we can barely comprehend but refuse to tell us what those depths contain. They are invitations without answers, promises without fulfillment, riddles that may have no solution, and yet we cannot stop looking at them, cannot stop wondering, cannot stop hoping that one night the pattern will change, the silence will break, and we will finally know. Until that moment comes, or does not come, we have this quiet hour between day and night, this space where thoughts slow and the boundaries of self begin to soften, this moment of suspension between waking and dreaming, where all things seem possible and nothing is yet decided. The theories we have explored are not really separate. They bleed into one another, overlap and intertwine. Perhaps the truth contains elements of many, or all, or none. Perhaps the question itself will evolve as we evolve, transforming into something we cannot yet articulate. What matters is that we keep asking, that we maintain the capacity for wonder even as we grow more knowledgeable, that we preserve the part of ourselves that can look up at the night sky and feel, simultaneously, utterly small and deeply connected to everything that is. Somewhere out there, beyond the reach of our instruments, beyond the horizon of our understanding, reality continues its patient unfolding. Galaxies spiral through their ancient rotations, stars ignite and fade, planets form and dissolve back into dust, and perhaps, on some of those worlds, other beings stand beneath other skies and ask the same questions we're asking now, or perhaps not. Perhaps we truly are the first, the only, the lone voice in an otherwise silent cosmos. And if that is true, then every word spoken, every song sung, every moment of connection between conscious beings becomes an act of defiance against the void, proof that emptiness can give birth to meaning, that silence can be broken by those brave enough to speak. The infinite night stretches above us, patient and vast and impossibly deep. It has watched civilizations rise and fall. It has seen species emerge from oceans and learn to walk and eventually turn their eyes upward toward the source of light. It knows things we do not know. It contains mysteries we have not yet learned to perceive. But it also contains us. We are part of it, not separate from it. Made of the same matter, governed by the same laws, expressing the same fundamental patterns that shape everything from atoms to galaxies. In this sense, we are never truly alone. We are the universe experiencing itself from within. We are stardust that learn to wonder about stars. We are the cosmos asking questions about its own nature. And maybe that is the real answer to the paradox. Maybe the silence exists not because the universe is empty, but because the universe is waiting to see what we will become, waiting to discover what consciousness, given enough time and enough courage, might evolve into. We are still so young. still learning, still stumbling through our adolescence as a species. Perhaps when we mature, when we grow into whatever we are meant to become, the silence will feel different. Perhaps we will understand it not as absence, but as potential, not as loneliness, but as invitation. For now, let the questions rest. Let the theories drift away like clouds across a darkening sky. Let the need for answers soften into simple acceptance of what is, the mystery, the wonder, the infinite night that holds us all. Tomorrow the sun will rise again. Tomorrow we will return to our lives, our concerns, our daily negotiations with reality. But tonight, in this quiet space, we can simply be. Simply exist alongside the stars, neither demanding explanations nor surrendering to despair. Simply breathing, thinking, wondering in this brief moment of consciousness we have been given. The universe does not owe us answers, but it has given us the ability to ask questions, and in that gift, perhaps, lies everything we need. Sleep now. Let the cosmic questions settle into dreams. Let the paradox of the stars become a lullaby, a gentle reminder of how much remains unknown, how much beauty persists in the not knowing. We are here, we exist, we wonder, and somewhere in the infinite night, among all the theories and possibilities and unanswered questions, that might be enough. The stars will keep their secrets a while longer, and we will keep our hope, and the universe will continue its patient unfolding, carrying us with it toward whatever comes next. Rest easy beneath this vast and mysterious sky. You're part of something greater than you can comprehend. You're made of ancient light and impossible chemistry. You are the universe dreaming about itself. And in this moment, that is all you need to be. Good night.